Yes, class. In the last class, we had started with laws of motion, chapter number 4 of your NCERT. So all the 3 laws we have covered. Quickly, let us revise them. First law was law of inertia. So inertia was the property to maintain its state, either its state of rest, state of motion, or state up in a particular direction. That is the Newton's first law. Then that also introduces you to the concept of momentum, that is the amount of motion contained in the body. So which is given by the formula P is equal to mv. Capital P is the denotation, not the small p. Then Newton's second law tells us that external force which is acting on the body, it is actually rate of change of this momentum. Rate of change of momentum is what we get as the external force, from which we obtain the formula F is equal to ma. Only Harsha is submitting her assignments. I have received and I have checked the assignments of Harsha only. Other students also try. I give simple questions in the homework. You have very simple 2 to 3 questions hardly. Usually you have 2 to 3 questions only. Please try them. And regarding the class tests also, very few students are attempting. Others also attempt. Then this was a very good conversion, which you have to remember. 1 Newton is equal to 10 to the power 5 times. Then the Newton's third law, which is action and reaction, which says that for every action, you have equal and opposite reaction. So that means what? See, for example, a very basic example, let's take, which is given in the NCERT, a person who is walking on the ground. So there are many things which occur when a person walks on the ground. Suppose you have striked up your feet, heel strike you have done. Then you have applied a force on the ground, right? So ground also applies a force to you, which is known as reaction force of ground. So this is your heel strike. We call it as heel strike when you place the foot on ground. So when you heel strike, force on the ground is exerted. And why don't you sink in, or why isn't there a problem in your body? Because you are applying force, there should be a problem in your foot, in your body, but there isn't any problem because equal reaction force is exerted back to the ground. So that balances, everything remains intact. Now, you have one more force, that is the gravitational force. So why are you not going downwards? Because the force below the axis is greater than the force above the axis. So see, because when you are striking, there is always one perpendicular force, which we say normal reaction. Normal reaction is always perpendicular to the surface. If I am keeping this here, normal reaction is in this direction. If my wall is like this and I've kept a box, something I've kept here, so normal reaction will be like this, always perpendicular. So this is what is known as normal reaction. So like this, all the forces will be balancing each other. You also have components like reaction force on ground. Here you will get R cos theta. Here you will get R sin theta. So every force, R sin theta, R cos theta, each has a function to play. Like R cos theta, this helps the person to walk, to produce the forward propulsion of the body, like this. And R sin theta actually helps in balancing of weight. There was one question, that's why I want to discuss this with you. This you have to explain it in your words, write it in your words also by explaining. R sin theta, when the reaction force on ground resolves into its two component. One will be R cos theta on the x-axis, other will be R sin theta on the other axis. So R sin theta actually balances the weight of the body, while this R cos theta helps the person to move, helps man to move. So there was one question, example based question from Newton's third law of motion, that explain Newton's third law with reference to a man walking on ground. So this is how you have to explain that when a person walks on the ground, when the heel strikes on the ground, there's a force exerted on the ground. To this action, there is an equal opposite reaction according to Newton's law, that is reaction force of ground, right? Now, this reaction force of ground resolves into its two component, that is r cos theta, which helps the man to move, and r sin theta, that balances the weight. Along with this, the normal reaction balances the gravitational force. This is how a man walks, and this is in correction with the Newton's third law of motion asleep. Now, the topic that we have to do is impulse, a very short topic, and the definitions are also very short. Just do one thing before we start with impulse. I want you all to just make this rough figure and quickly write it in your words. All right, quickly write it in your words. If you get stuck, if you want me to repeat, I'll dictate it also. But I want you all first to write it because this question has come once. Note it down, then we'll discuss impulse. Done?
Yes, ma'am.
See, what is meant by impulse? Impulse is actually a force only. SI unit is also Newton. Everything that you study regarding a force, this is exactly impulse. Push or a pull, we say no, force is a push or a pull. So that is impulse only. But how can now we differentiate between an impulse and a force? See, impulsive forces are actually one type of force. Force is a very broad term. So under which impulsive force is a narrower term. Impulsive forces means forces which act for a very, very short duration of second. For example, if a ball has been thrown and you hit it with a bat, so there is a force that occurs on the ball because of hitting of bat when both of them get in contact. But what is that duration? It is so small, it is in seconds actually. Sometimes it is in milliseconds also. When the ball strikes the bat, the surface of bat and repels back, right? When the ball comes and pushes back from the same path or a different path, that force that occurs on the ball due to the bat because of this very short interval, that is what we called as impulse. Or you can take so many examples are there. If you are putting a nail into the wall with the help of hammer, you struck the nail with the help of hammer, so the duration, I'm not talking about the entire process. When you are playing cricket, that entire process, and when the nail has been fixed completely, that entire process. No, I am talking about the moment of contact, duration of time, or the force that acts for this short duration when both of them are in contact. So if we are stucking a nail into the wall with the help of hammer, so that moment when the hammer strikes the nail is for a very short second because we push the hammer back and then we strike it again and then we push it back. So that duration is very small. Now the type of force which we get, that we call it as impulsive force, or in simple language we say it as impulse. Same things, rate of change of momentum, everything, push or pull, same it is. It's just that force is a broader term. All right. So yes, impulses, examples I have given you. Impulsive forces are forces which act for a short duration of time. It's like, no, if even if you try and plot its graph for it, forces, nothing is occurring, Suddenly the forces occurs for this short span of time, and this force is a variable force that occurs, and then again it stops. The force increases so much and then suddenly stops within that duration of second. That is what is known as impulse. Formula is there. A little difference in the formula occurs, a little difference, because impulsive forces are for short duration of second. So if for 1 second you are having, let's say, F Newton, so for t number of times, how much impulse you will have? F into t. So that is the formula of impulse. It's like unitary method. For 1 Newton or for 1 second, you are having F Newton. For 1 second, you are having F Newton. So for t seconds, how much newtons you will have? F into t newtons. This is why we exactly do not have. Otherwise, we don't need to study impulse separately. Whatever you would have studied there, I would have just given you this definition and we would have stopped it. But the differences are there in the formula and everything. It is the total impact of impulsive force. It is the product of average force and time of contact. Why? Because see, impulse will be now whatever average force occurs multiplied by time. That is F into T. F into T. And delta T is what? Delta T is the time of contact. This is important because some students, while calculating, they consider the entire duration of the process. If one car is moving, another car is moving, they have collided, they have met with an accident, they have collided, and they are now back. So whatever the force was for that particular small duration, that will be the impulsive force. You do not take the entire journey's time period. You do not take. You take the time instant. That is the time of contact. Clear, class? Now forces, now, so what will be the, what is the average force? Average force we used to calculate, no, dp over dt, rate of change of momentum, or you can take it as delta p over delta t also. You know when to use which formula. If you are having variable, or if a particular time instant is given to you, exact time instant, you differentiate. If average you have to find out, that is a beginning and a duration you have, you take out this. But what this still remains is change in momentum. And what is this? Time duration, right? Time duration. ठीक है? यहाँ तक change in momentum by time duration. Now, what will be the effect on impulse? Impulse is already force into time. And what is force? Delta P by T into T. So, impulse is exactly the change in momentum. So, do you need to learn anything else? Do you need to solve separate questions? Do you need a new formula? No. Momentum you have already studied in the last class. You get your momentum, you get your impulse. But impulse is not, is actually a type of force. Because it occurs for a very short second, that's why it becomes the momentum. Otherwise, its properties are similar to force only. Quickly note it down. We'll practice some questions from this now. Yes, direction is also same as that of force, and SI unit is newtons into second. Or sometimes you will also find kg meter per second sometimes, but to differentiate impulse, usually the actual SI unit no is Newton seconds, not kg meter per second. But somewhere it can happen that you are finding this. We'll practice one or two questions from momentum, impulse, all the combined questions from the last class, noted down. Then pulley problems also we'll do today. Harsha, did you receive the playlist?
Ma'am, I'll check and tell you.
Check.
Yeah, ma'am, I got it. Thank you.
See, question says that you have to find out impulse imparted on the ball. If the time of contact is 0.2 seconds, calculate the average force. Let us go by the first part. And one more thing, see, two directions are given. Mirror is there, ball has strike. Now ball is bouncing back in the same direction. This is what is given in the question. So we have to apply the sign conventions here because two directions are mentioned. I have always told you in one dimension, two dimensions, you have to apply the sign convention. Choose any. Let's take this as positive. Let's take this as negative. Sign convention, you are independent to choose any type of sign convention. Impulse is asked. Impulse is what? It is actually the change in momentum. Impulse is the change in momentum. So momentum is final momentum minus initial momentum. Now let us calculate the initial momentum. Yes, Martin, what is the formula of momentum?
MV.
MV, perfect. Formula of momentum is mass into velocity. See, mass is given as 5 kg for the first body and velocity is given as 10. So that becomes 50 kg meter per second. P2 formula will be MV. Yes, Sarah, can you tell me what would be P2's value?
5 into 10.
How much?
5 into 10.
5 into 10. This you're saying?
Yeah.
Then why are we getting a different answer in case of relative velocities? There is something that we apply which changes our answer. Sign convention. Why did we take sign convention? If you are taking this side also, right side also positive and left side also positive, your answer will be same. Finally, everything gets cancelled. Your answer is 0. You will get exactly opposite answer if you do not apply sign convention. This is minus 50 kg meter per second. Otherwise, if you do not apply sign conventions, this will be also 50. 50 minus 50, it would be 0. Whereas the answer is P2. What is P2? Minus 50. Minus what is P1? 50. Your answer is minus 100 kg meter per second. What is this minus sign depicting? That the direction is towards negative. So direction is towards the left. That is the negative x-axis. I can put minus I cap also. Second part, we have to find out the force. See, force is unknown. Time is also given. Impulse is minus 100 kg meter per second. Force into time. How much time is given? 0.5. No, I think 0.2. This is 0.2 seconds. So force will be, now you can take the magnitude over here because in average force, though you can write it as minus also, but usually for the formula of impulse, we take it as the magnitude. So you can take it as 100 divided by 0.2, 1000 by 2, that is 500 Newton will be your answer. Because impulse's direction we have already specified. Fine, note down the solution. One more question we will do before going on to Pulley problems. Quickly note it down. Yes, average force, you have to take the magnitude only for average force. In cases of impulse, only in impulse, not otherwise.
Okay, ma'am.
See, the question says that a ball of mass m with speed v strikes a wall and rebounds with the same speed. Calculate the impulse. So question is same. Difference is that here velocity is at an angle. So if it is at an angle, it means we have to resolve the components. You have to resolve it like this. So if this is theta, alternate angles, this will be theta. So this becomes v cos theta. This becomes v sin theta. Fine. Then this velocity, again, you will resolve this also. If this is theta, this will also be theta, corresponding angles. This becomes v cos theta and this becomes v sin theta. Now solve everything according to x-axis and y-axis. Impulse along x-axis will be final momentum along x-axis minus initial momentum along x-axis. What is the final momentum along x-axis? Finally, this is v cos theta. See, again, we have to choose the sign convention. Let's take one side as positive. Let's take this side as positive and opposite side as negative. So this will be minus v cos theta. This will become m minus v cos theta minus p1x mv positive cos theta. So that makes it minus mv cos theta minus mv cos theta, that is minus 2 mv cos theta. This is impulse along x-axis. Now impulse along y-axis. This will be final momentum along y-axis minus initial momentum along y-axis. See, final momentum along y-axis. This is your final momentum. Yes, Harsha. What is the final momentum along y-axis? Final momentum.
Minus v sin theta.
Minus mv sin theta. Very good. This is minus mv sin theta. All right, this is minus mv sin theta. Now minus sign. Now initial momentum along y-axis. Again, here also we didn't choose any sign convention, no? We have to take a particular sign convention. Let's take downwards as positive only, or let's take it as negative since we have written no negative. Let's take downward as negative. Yes, Siddhika. This is the velocity acting in downward direction. Downwards direction. What would be the momentum? Momentum's formula. What is the formula of momentum, Siddhika? Minus mu. C minus mv sin theta. Velocity is v sin theta acting along y-axis. Okay, Siddhika? So this becomes minus mv sin theta. This will cancel minus, sorry, this is minus, no. So that becomes minus mv sin theta plus mv sin theta, which cancels, which means impulse along y-axis is 0. See, even if you take the sign convention downwards as positive, it would be, if sign convention downwards was positive, then also mv sin theta minus mv sin theta would have given you 0. So choose any sign convention. I am telling you, you will get your answer exactly same. What would be the resultant impulse? Resultant impulse would be ix plus iy. Since iy is 0, your net answer of impulse is minus 2 mv sin theta. If there would have been some value of y, that would have been added in your final answer. Note this down. Now we will solve Pulley problems. Quickly, we will just see in brief how to solve it. We will not go into the details of it because only one type of question is there in your syllabus. We'll just have a brief look of it so that we can properly give time to friction. Friction is there in your syllabus in detail. Sorry, this was mv cos theta, no? So this is cos theta. See, pulley mass system, just one concept you have to remember. Based on that, all the questions will be solved. See, how do we write it? In a pulley mass system, a pulley is given to you and two masses are given. Let's say this is a block of mass M1 which is tied to one end of the string, and this is block M2 which is tied to another block of the string. Siddhika, by looking at the figure, which block do you think is heavier, M1 or M2? By looking at the figure which I have drawn. M2, very good. So it means we have assumed M2 is greater than M1. Now, one force that is being introduced to you right now is the force of tension. Tension is the force that acts along ropes or strings. This is directed away from the body. Direction is away from the body. So here also what will happen? Tension force will occur. Here tension, here also tension. Away from the body, away from the body. But since this is the same wire, a same wire has been wrapped around the pulley. That's why we have taken the same tension. If these were two different wires, two different strings, two different ropes, we would have taken two different values of tension. Means T1 and T2 we would have assumed, T1 and T2. But since this is one single rope, and you usually in your CBSE syllabus, you have single rope problems only, which will be given. If it's a different rope, that would be given specifically. Or you'll be able to figure it out from the given diagram. So from this figure, you can see tension is moving away. Any other force which you feel is acting? Tension is one force which I have told you. Any other force which you think is acting?
Gravitational force.
Very good, Harsha. Gravitation force. So formula of gravitational force is mass into acceleration. And acceleration that occurs in vertical direction is acceleration due to gravity. So the force, gravitational force directed because of M1 mass will be M1g, and this force will be M2g. Let's assume the accelerations. This body is going up because this is lighter, so this will go up and the heavier one will come down. This is what should happen accordingly. That's because of this condition. So acceleration here and acceleration, this is coming with acceleration A downwards. Now remember, the force which acts towards the acceleration, we consider it as positive. Now, what are the sign convention in your pulley system? Forces acting in the direction of acceleration are taken positive and other forces acting in opposite direction are taken negative. This is one sign convention. All right. And net force of the body is actually mass of body, mass of the system, mass of body is which you have got, multiplied to acceleration. That is acceleration due to gravity, which we assume. That's why m1g, m2g we have assumed. So let's write the equation for the first block. This is your first block. This is your second block. How do you write the equations of these? First block. Now, net force is mass into acceleration. F is equal to ma. But F is equal to ma is equal to what? This is one force acting. This is one force acting. So the force along the direction of acceleration, this becomes positive. And for this block, this becomes positive. So what is the force that is acting towards along the acceleration? See, acceleration is upwards. Only tension is upwards. So tension will become positive. Fine. What about acceleration due to gravity? Acceleration due to gravity is acting downwards. And since this direction is positive, downwards will be negative. So this becomes minus m1g. Now this is equal to the net force. And what is the net force? Mass of the body into acceleration. What is the mass of body? m1. What is acceleration? A. So this is equal to m1. Coming to second block. Force directed towards acceleration will be positive. So now m2g is positive because this is acting downwards along the direction of acceleration. So this would be m2g minus tension, because tension is acting oppositely, is equal to m2ga. This is the equation which you actually obtain, m1a and m2a. Fine. Your main equation is F net A. Now I'll tell you how to draw free body diagram here itself, because free body diagrams will be used now onwards in your friction also. See, free body diagram means if you are focusing on one object and then you draw all the forces which are acting on that object without drawing anything else in your system. That is what is meant by free body diagram. Free body diagram. FBD, free body diagram. So just take the object. Step one is take the object and draw all the forces acting on it. For example, if I talk about FBD of block 1. So in FBD of block 1, this is block M1. This is tension acting. This is M1G acting. This is FBD of block 1. Right? If suppose one more force was acting, let's assume that here one more force is acting. So now FBD will look like this. So net force upwards will be F plus 2. Fine. But since nothing is acting right now, I won't draw. This is the first block. Regarding second block, this is M2. So tension was acting here. M2G was acting. Like this, we draw the F body. You just draw the object, take the object and draw all the forces acting on it as if no other object is existing in your system. Even if another object is exerting a force on this, now draw that force anywhere in your system, but do not draw that source of force. Right? This is what is the concept of Pulley mass system. So you just have to make the equations like this. Some questions I'll give you in the next class. Today we'll start with friction first, because the questions actually involve friction. Without friction, we won't be able to solve most of the questions. But start noting it from here. Any doubts if you have, you can ask in meanwhile.
मैं go back. You can go down.
All right, class. So you do not have your class assessment today. Now we are left with two topics. Actually, we are left with friction. Friction is a major topic which we have to cover from this lesson. I will do circular motion in this lesson only. You have circular motion as a part of your work energy and power and rotation. But I prefer to do it here only because all the forces which are involved there, they are used at one place. So we'll do circular motion also here. Now friction is left. So by the next week, we should be able to complete with this lesson. All right. So no assessment today. You all can leave. Thank you so much, class.
Thank you, ma'am.
Thank you, ma'am.
Thank you.